Continuing on to part 2 of this lecture, we'll talk now about Amundsen's law. Amundsen's law, you might have figured out by now, is the relationship between pressure and temperature. It states that if you keep the volume of a gas constant, the pressure and the temperature of the gas are directly proportional. Again, if one goes up, the other goes up. If one goes down, the other goes down. And so the temperature has to be expressed in Kelvin. And the relationship is very similar to Charles' law, except you substitute pressure for volume. P1 over T1 is equal to P2 over T2. And again, you have a positively sloped line with the relationship of temperature and pressure. The first one is a gas has a pressure of 0.370 atmospheres. P1 equals 0.370 atmospheres at a temperature of 50 degrees. T1 is equal to 50 degrees centigrade, and if you add 273.15 to that, you get 323.15 degrees Kelvin. What is the pressure at standard temperature? Now, you don't know this, but you're going to know it now because I'm going to tell you. Standard temperature is 0 degrees centigrade, or it's 273.15. So the question is, what's P2 now? So we had P1 over T1 is equal to P2 over T2. And we want to know what P2 is. So we cross multiply. P2 times T1 is equal to P1 times T2. Solving this for P2, we get P1 T2 over T1. Put the numbers in and we get 0.370 times 323.1. Oh, I got the wrong number. I'm sorry. Let me erase that. Times 273.15 divided by T1, which is 323.15. Okay, the answer on the calculator is 0.3127510. This is the three significant figures. There's a 0 in here, so that's three significant figures. So the answer should be the three significant figures, so it's 0.3 atmospheres. The second problem states the temperature of a sample of gas in a steel container at 30 kilopascals, that's just another measure of pressure, is increased from minus 100 degrees C to 1 times 10 to the third degrees C. What is the final pressure inside the tank? Again, we have P1 is 30.0 kilopascals. T1 is minus 100 degrees, so that's minus 100 degrees, or if you add 273, you get 173.15 degrees Kelvin. P2 is what you don't know, and T2 is 1,000 degrees, okay? 1 times 10 to the third, so that's going to be 1,273.15 degrees Kelvin, adding 273 to 1,000. And as it turns out, again, we don't have to go through this again because we've already done it once. P2 is going to equal P1 T2 over T1, which is going to equal 30.0 kilopascals times 1,273.15 divided by 173.15. The answer in the calculator is 220.5862. And again, this is two significant figures, three significant figures here. No, excuse me, this is three significant figures, 1, 2, 3, four significant figures here, three significant figures here. So the answer should be to three significant figures, or 221 kilopascals. Every answer has a label. The atmospheric pressure is the weight of the atmosphere at any given altitude, and it measures approximately 101.3 kilopascals, or 1.013 times 10 to the fifth pascals. It does change depending on what altitude on the Earth you're at the time of the measurement. A barometer is an instrument that measures air pressure. So here's a barometer, and this is how a barometer works. The air pressure pushes on this pool of liquid, in this case mercury. This area here has no atmosphere at all. The pressure in here is zero. And so however much pressure is pressed down on this pool forces the mercury up to a certain height, until the pressure caused by the column of mercury is equal to the pressure caused by the air pressure that's pushing on the pool. And when we talk about 760 millimeters of mercury or 76 centimeters, that's just the distance from the level here up to the point of which it's pushed the column up to. This can also be in terms of inches. And here's a different kind of barometer. This is called an agromic barometer. And what happens in here is you have, again, a vacuum capsule that when the air pushes on it, it causes this to turn. And this turns, and this basically turns this dial and measures it out that way. An altimeter is a device that measures altitude. The altitude is measured based on the idea that the atmospheric pressure decreases as the altitude increases. And so you set the altitude at zero when you're on ground level, and that pressure is then equated with zero altitude. Then as you go up and the pressure decreases, the altitude will increase. It measures the decrease in pressure and measures that as an increase in altitude. Everyday atmospheric pressure, fluids will always flow from areas of high pressure to areas of low pressure. So we have the idea of a siphon. A siphon will drain liquid from a vessel that is at a high level to a vessel that is at a low level, because fluids will always drain in that direction. You can always drain a fluid if you can put one of them at a high level, the one you want drained, and the other at a low level. So here's an example of a siphon, and the flow of the fluid will be from this high level here to this lower level here until this is empty. And what you can see here is basically the fluid has to go up this high, move, and then it drops down to this level. And the difference here is equal to atmospheric pressure pressing here plus the density of the liquid times gravity times the difference in level. So this difference times this density of this times the gravity is the force that pulls down on this, in addition to the fact that you have atmospheric pressure pressing here. Because this is not filled up to the tube, atmospheric pressure has no impact here. So how does breathing work? Breathing is a very interesting process. Breathing is a way of transferring air from an area of high pressure to an area of low pressure. So here's how breathing works. When you inhale, look at the diagram on the left. When you inhale, the diaphragm pulls down, and at the same time the chest wall muscles pull out. Both of these actions, the downward pull of the diaphragm and the outward pull of the chest wall muscles, tend to increase the volume of the chest inside the chest wall. It is airtight, and assumed all of this is at the same temperature, approximately the same temperature. And so what happens is you increase the volume, as it says here, what happens? It decreases the pressure. So the pressure here becomes less than the pressure out here. And because the pressure in here, inside the chest, inside the lungs, is less, then air flows through the open nose, down the trachea, and into the lungs. Now, what happens when you expire or during expiration? It's all here on the right. On the right, you see that diaphragm moves up. It just relaxes to its normal position. The chest wall moves in on its own, and the volume decreases, so the pressure increases and causes their increase in pressure inside the chest and forces air out into the atmosphere. Inspiration is an active process requiring the contraction of muscles. Expiration is a passive process that requires no muscular input. Normally no muscular input.